Hello everyone. So today we will be reverse engineering boot.img. About me, I'm an independent embedded Linux Android AOSP ROM developer. I am also a Linux kernel contributor, more than 12 years experience. Below are my email addresses and website if you want to contact me. Now what is boot.img? It is one of the most important partition images and it contains Linux kernel and RAM disk among other things. It is used during the boot up of the operating system. So when your device boots, at the very start we have the bootloader, and then after that this boot.img is executed. It initializes important hardware pieces and then it starts the init process. Now, as we can see, we have this boot.img in our folder, and next we will be extracting the contents from this boot.img, basically reverse engineering. We will know all the details and other important information regarding the components. So let's start. So now I have downloaded from the internet a tool which is here, as you can see, magisk boot_x86. Now using this tool, I will extract the contents from boot.img. Let's see this in action. So the name of the binary, then the option that I will give is unpack, and then the name of the file. I will press enter. As we can see, it has printed out some information on the console, and also if I will now check the contents inside this directory, I will do ls, and as we can see, we have obtained 3 more files which are DTB, kernel and the RAM disk. So now we know that this boot.img contains DTB. What is DTB? DTB means device tree binary. We have the device tree source, and when it is in compiled form, it is called device tree binary DTB. And then we have the kernel, the core piece of the operating system, and then we have the RAM disk. Now let's dive little deeper and let's check more information from the header. Now let's look deeply into the information that we obtained when we ran this command, magisk boot unpack boot.img. Here we see kernel size as mentioned here, which is present inside this boot.img. Then RAM disk size, other information like page size, the command line. So at the initial stages of the boot, we have to pass the command line, then this checksum, and then this format. But we can see that the kernel load address is not visible to us. We cannot find the kernel load address because at the starting phase, kernel has to load somewhere, right? At some address in memory, kernel has to be loaded. Now what is that address? We can't see clearly, so let's try to get that information also. Now to get the header information, which usually holds the kernel load address, we just have to pass a special flag while executing magisk boot command. Let's see this in action. So the usual thing, unpack, and then I will type -h and then boot.img. I will press enter. Now let's see the contents. As we can see, one more file having the name header has been generated. So let's open this header file and check its contents. So here we obtain OS version, then the command line, and then the patch level. But again, we cannot see the kernel load address. So basically kernel load address is one of the most important information, because if you are porting, for example, if you are porting this Android AOSP into some other ROM, then you will be needing this kernel load address. So let's do something more to finally get the kernel load address. Now, to get the full header information, including the kernel base address or the kernel load address, we can use another tool which is called boot.img. So to install that tool, you can simply run sudo apt install boot.img if you are in Debian based distribution. I have already installed that tool. Now using that tool, I will try to extract header information from this boot.img. Now let's do that. So the option that we have to pass is -i and then the name of the file, which is boot.img. And now let's execute this. So as we can see, we have these informations, but here we can find the load addresses of each of these components, kernel Ramdisk tags, and of course we have command line and other information as well. So the information that we were searching for, which is the kernel load address or the base address, is this. Similarly for Ramdisk. So I hope you like this video regarding reverse engineering of boot.img. We extracted different components. We also looked into different addresses. Now, why are these values important? Because for example, as I already said, suppose if you are porting from a stock ROM to a different ROM, then in the board config.mk inside the device tree source, you will have to specify these values, okay? You have to tell the system where will the kernel load and related things, and of course kernel size and all that. So I hope you like this video. If you have any questions, please ask in the comment section, and thank you for watching.